and try to make sure you understand the difference between when they say find the area of something versus the perimeter of something, or find the volume of something versus the what? The surface area or whatever. But anyway, it's some of the things that I want to go back and review just a little bit about to make sure you're all on board. Some of you may be, because you've taken a class from me somewhere along the way, and you may have heard this already, so just bear with us for just a second or two. And that is, let's go back and think about what we do this stuff called math with. We work with what? We work with a system called a real number system. And you identify that. You can say, this is the set of all reals, and they make some kind of symbol look like that. So that just means that represents the set of all real numbers. Now, go to the next question. So it's, but it, but if, you know, if we talk about the real number system, you know, how do they normally teach you about the number system? Did they do something like this? Like that? Talk about the numbers going what? The positive numbers, the negative numbers. Well, we'll certainly have to know about the numbers called the real numbers, but if you stepped out of the numbering system into another numbering system, you would be in something called the complex numbers, and we will work with complex numbers even in this first chapter or so of your work. Complex numbers, gee whiz, mathematicians work with them for quite some time, and they learn to add, subtract, multiply, divide them. Some bright guy comes along and he decides, wow, why don't we write these in trigonometric form? And then, of course, a young man by the name of Leonard Euler comes along, and he figured out a very clever way to write it in exponential form. Probably one of the most clever things in math that you ever encounter is how he went about doing that. But we will talk, and of course, just like the mathematicians of those days, they were scolded. They were scolded by other mathematicians for doing what? Wasting time, working with a system of numbers that was sort of useless and of no avail. And which turned out to be what? To be false, because what happens when somebody comes along and discovers something called electricity? Yeah, okay, electricity. They discovered electricity. They still don't know what the hell it is. No one knows what it is. They only know how it behaves. And if you want to know how it behaves, just stick a wire in this socket up here, and you'll learn real quick how it behaves. AC electricity, and guess what? They discovered that the way to solve the AC electric problems was what? Through complex math. It doesn't say that runs off complex mathematics. It's just a very convenient way of solving some of the problems in electricity and AC circuitry is with the complex numbers. So, all right, what if you take a step backwards into a second set of numbers that we deal with quite often, called the binary numbering system? And again, what happened in that case was what? The mathematicians learned how to add, subtract, multiply, and divide them, do all sorts of stuff with the numbers, and they were scorned at for wasting their time working on math problems that was to no avail. What are you going to do with this stuff? And then what happens? Somebody comes along and invents a computer.
They want to know how that works. They want to know how that works too.
Well, how do you suppose the computer works? I don't care if it's this calculator or whatever, the telephone or whatever that is, or that calculator, or the most powerful calculator or the most powerful computer in the world, the Crane. There's two of them in existence. The United States government owns one. Who owns the other one?
China.
Russia.
Oh.
Japan.
IBM.
Oh.
The European Union.
Russia?
You may have heard of this company before. You ever heard of a company called Walmart?
Yeah.
Anybody know Walmart? Y'all heard of them?
Yep.
They own it. In Bentonville, Arkansas tonight at midnight, they will tell you exactly how many pinstripe long blue shirts were sold in this area, and they can divert their trucks no later than 9 o'clock in the morning to different locations. All because they do what? They have this powerful computer system that they can feed and get data back from rapidly. So, yes, it is Walmart. They own the other one. Very, very powerful system. So, but what is the binary numbering system anyway? What is the binary numbering system?
Ones and zeros.
Is what?
A language consistent.
Ones and zeros, right?
Yeah, it's a language.
So what do? They just figured out how to do what? Take every single number and change it to binary. Y'all know how to do that? Did I change the number to binary? Change 48 to binary. Just divide this by 2, you get what? 44 with nothing left over. Divide this by 2, you get 12 with nothing left over. Divide this one by 2, you get 6 with nothing left over. Divide this by 2, you get a 3 with nothing left over. Divide this by 2, you get what? 1 with 1 left over. Divide this by 2, you get what? 0 with 1 left over. You write it from the bottom back to the top. That's binary for 48. It's a very simple way to do it. So, when the computer comes along and somebody designs this really neat machine that does what? Calculates and does all this fancy stuff for us. And guess what? That powerful machine, no matter if it's that machine or that machine or that one or whatever, it only knows 2 things. It only knows 2 things, and what is that?
Ones and zeros.
Ones and zeros.
Ones and zeros. I'll tell you what to do. Take this calculator, and you may use it like a telephone,
Okay.
but that's okay, you can do that. And you may have to talk loud, but tell it 0.
0.
Hell, I don't think it hurt you. How about 1?
1.
Okay. Gee whiz. So Helen doesn't understand zeros and ones. It does not understand zero. What the hell 0 to 1 is? Did it? Did he come back and say 0
My
to you?
phone will do it.
No, it does
if
not.
I yell 1 or 0.
It doesn't know what zeros and ones are. It only knows two things, folks, and that's whether the circuit is off or on. Man has fooled that machine into believing that if the circuit is off, there's a 0 in its register, and if it's on, there's a 1 in its register. So if the circuit is on, off, what comes on the screen? A 48. Doesn't know what the hell 48 is. It just knows it's what? On, off. Man fooled it into believing that when it prints up on the screen, a 48 comes up. That machine doesn't have a clue what 48 is. It only knows if it's off or on. So with that being the case, all of a sudden, all the work that the mathematicians have done converting numbers to the binary system turned out to be what? Be very worthwhile in the end. So you can't say that it was not, even though they were scoring that for quite some time for wasting their time with the binary numbering system. Now, let's go back and talk a little bit about the what? Our real numbering system that we deal with quite a bit. I'm always surprised, I guess, in a way, when I teach an algebra class and I start asking questions about none other than the numbering system. Our numbering system. And guess what? Hell, they know very little about it. And I'm sort of puzzled. Why is it that you know so little about our numbering system? The fact is, nobody probably told you about it. Our numbering system. How much thought have you given to it? How much thought have you given to our numbering system?
0 or 1.
How much thought have you really given to it? Because you have to know that there are two types and only two types of numbers on our numbering system. And what are they?
Real numbers and binaries?
Binary.
Binary?
Two types of numbers.
0 and 1.
Rational, irrational.
They are rational or irrational. Period. Now don't go and look up what the hell a rational number is, because it's going to say a number that's not irrational. And go look up irrational. Guess what it's going to say? A number that's not rational. Gee whiz. Gave us a lot of information, right? Tremendous amount of information. So, let's define what about our numbering system? We know for a fact that all the integers left to right are what?
Real.
Are rational. They're rational. Okay, so if that's the case, name me an irrational number.
-8.
Yeah, you didn't listen to what I just finished saying. I just finished saying to you all that hell all the integers from left to right are what? Are rational. Now, I ask you a simple question. Name me an irrational number.
All the numbers that aren't from left to right.
To now. Name me what? Well, the thing about it is, I can ask the question to folks, and guess what? I hate to tell you, but there are more irrational numbers than they are rational. The hell, you can't name one. So, you haven't given much thought to our numbering system, have you? You haven't given much thought to it. But we need to. We absolutely need to, because if we work with these numbering systems on a daily basis and we do stuff called calculus, then we have to do what? You better know how they behave. I'll ask another question, okay? How many in this room have truly examined all the numbers in our numbering system? Have you ever examined all of them? Hell, have you ever thought about it? Raise your hand if you've ever thought about examining all the numbers in our numbering system called the real numbers. Gee whiz. Now, see, you haven't given damn much thought to what our numbering system is. You know why? Because you only have to look in one location. And when you look in that one location, you've examined all of them. Every single one of them. You only have to look between 0 and 1. What do you suppose is between 0 and 1 versus 1 and 2?
Half. 0.5. The same thing.
What happens? What's the difference between what's between 0 and 1 and what's between 1 and 2? Or what's between 4 and 5? You know what? Have you ever thought about this? They're exact copies. 0.5 lies between what? 1 and 2, right? But hell, somebody sticks a 1 in front of it. Somebody does what? Somebody takes a rational number and sticks on the end of it. So big deal. Big deal. So to examine all the numbers, you only have to look in that one location, and that is where? Between 0 and 1. So what's between 0 and 1?
Everything
You look right there, and you're going to see the same copy between these two versus the next set, versus the next set, versus the next set. And the same way that direction, somebody will just put a minus sign in front of it. What difference does that make? To make it really compounding is the fact that if you think about doing this, if you think about grabbing two numbers in between 0 and 1, and I want you to mentally choose two numbers so close together you can't imagine anyone being between them. And when you do, and no matter which two numbers you tackle, I can show you with the Compactness Theorem that in between those two numbers you've chosen, there lies an infinite number of rational numbers. And in between each of those infinite rational numbers, there lies an infinite number of irrational numbers. Now, if your head and your head's not saying overload, and your mind's not saying overload, 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 then you're not thinking about a darn thing about what I'm saying. Your brain should say what? It hurts to think about it. Because our real number line, folks, is not on that board. That real number line can only exist in one location, and that's where? That is in your mind only. You cannot make a line. A line only has one dimension, and that is what? Get off Facebook if you're going to be in my class. I don't want you over on Facebook and stuff like that. Now, it's one-dimensional. You can only put something in your head in a one-dimensional state.
What about when you're watching a 3D movie?
Oh my God.
Can't, because even if I do this, is that number line. I let it dry, and you give me a magical razor blade, and tomorrow I can come along and I can possibly do what? I may be able to scrape this thing off and literally hold it up, and now the line that you said that was the line is now not only one-dimensional, but it's what? It's three-dimensional. I'm holding the line up like this because it's like dry paint. So, a line can only exist in your mind. And because of that compactness theorem, because all the irrational numbers lying in between all the rational numbers in infinite form does what? makes the line solid. That's what makes the line solid. Not this chalk, not this marker, but it's the fact that the compactness theorem does what?
Make it solid.
Jams them all together where they do what? They bleed over into each other to make the line solid in order to make calculus work. Because what the hell would have happened if you'd have gotten up this morning and on the news they said somebody last night stole all the irrational numbers? You thought about that? Well, think about it. Because what would the number line look like?
Without irrational number.
If somebody took more than half of what you owned, would you miss it?
Depends on if it was my
Yes, you would. And you would miss half the numbers. They've stolen over half your numbering system. It would be what? It would be gaps or holes in the line. You could not go from 1 to 2 smoothly like you do for calculus. You've got to be able to continuously have a continuous line called a continuum. Otherwise it wouldn't work. The math would not work. So, that being the case, what actually constitutes a rational number? That beats what? If you looked at the real number line and you took out all the rational numbers, we've already decided that all the integers are rational, right? They're all rational. So now we only have to examine what? The decimal numbers. And if a decimal number, if the decimal comes out even or repeats itself, they are what? They are rational. It is a rational number. It is those that do what? That do not come out even nor ever repeat themselves are irrational numbers. So when I asked you to name me one a minute ago and y'all stumbled, why? Why, I must ask you, why did you stumble and you couldn't name one? Did you name one? No, why not? Say it. But hell, we don't care. Do you care if that number is irrational versus rational? No. I think she said, she named me one a minute ago, the second most important number in all the world, which was what? Pi. What's pi? Listen what I hear.
3.14.
3, what?
3.14.
Now damn, just quit? What'd you do? Why'd you quit? You should have said what? You should have said 3.14 dot. Okay, yeah, because it does what? It goes on forever, never repeats itself, and never comes out even. So what did she just do? She rounded the fool thing off like we always do. So did you care? Did that make a difference to you? Did you realize you were handling an irrational number?
Not really.
No. Golly. She had an irrational number. Just like we do what? The 0.333. Is that a rational number? Yes, it is. Why? Because it does what? It repeats itself. What do you do to make it go away and fix it? Do you ever use 0.333?
Not that I know of.
No, you don't. Yeah, you do.
Gas price is 0.999.
No, I round mine off to like.
So you do what? You round them off. You just truncate what you don't want, just like you would a rational number versus an irrational number. We don't really care. But you really need to know that there's a great difference between the two of them. Don't you dare leave this room. If you don't get another thing out of my class today, you better not leave here without knowing this. And that is this, that all rational numbers can be written in fractional form, an irrational number cannot be. Did you hear what I just said? How many of you heard what I just said? How many of you understand what I just said? I'm about to find out in a second or two. No, I will. I'll find out. So what does that actually mean, truly? And this is what they should be instilling in kids in middle grades, pounding into their heads the fact that what? If someone gives you a fraction and they tell you to turn it to a decimal, they get frightened. They don't know what the hell to do with it. They don't know. They just have to go either relax and say, what? When I change it to decimal, because it is a fraction, it is a rational number, it's either going to come out even or start repeating itself, so I really don't care how far I take it out, because I know it's going to do one or the other. There are kids today that don't know it does that. People today that do not know that all fractions will do what? Either come out even or start repeating themselves. So all the numbers I've written on the board are rational numbers, which means what? That they can be written in fractional form. Who will take a stab at the first one?
I will.
What is it? If you're going to do it, you better do it right. I don't want to make a mess out of it.
1/2.
The hell, you just made a mess out of it. Y'all going to sit there and let her get away with that? This is what?
0.5.
How the hell did you go from this to this?
I divided it.
No, you did not.
Yes, I didn't.
How did you make this quantum leap from this to this, and you all not stop her and question how?
It's 5/10.
It's 5/10, dang it. And 5/10 can be reduced to what?
1/2.
1/2. Don't go jump from this point over to this without questioning how the hell you got there. Because do the second one.
25 over 100.
Okay, it's better than 25 over 100, which reduces to what?
1/4.
1/4.
Final one that thinks 1/3.
The next one.
Final one I think can be reduced to 1/3.
I said the next one.
1/16.
I want the ones that had their hand up a while ago to answer my question.
It's 1/3.
What?
1/16.
1/3. 1/3.
You cannot reduce an irrational, you can't turn it into a fraction.
Anybody question that?
I question it.
Why would you question that?
Because he ain't right.
I want to know how the hell you got there.
Because that never comes out to an even number.
It's what now?
It never comes out to an even number. Like, yeah, it repeats itself.
What?
But no matter what, that will never get you to a 0.
Now what now?
Will never get you to a 0. 33 over 100 will never get you down to the perfect rational number, ever.
What do you mean?
Well, look at
I just got through telling you all. Right.
You can
That all rational numbers can be written in fractional form. Woo! Did I not say that? Did I not say that?
You're right. I'm saying that's not a
Yeah, that's a rational number.
How?
Yes, it does. Because by definition, it says all rational numbers either do what? The decimal either comes out even or they repeat. Oh hell, I gave you two harder ones. Let me give you an easy one. Let me give you this easy one.
Okay.
Is that rational?
Yes.
Yes! Can it be written in fractional form?
You're right.
That's exactly. What is that? It's a fraction.
I got you now.
What is that? It's a fraction. What is that? It's a fraction. Hell, you all know what that is. Y'all know that's what.
1/7.
You know that. You should have known that. Right.
I did know that.
I'll tell you what I'll do. There's some money. I think 55 cents. You come show me how you get 1/7 and you pick that 55 cents up and take it on with you.
How about give me an A? If I tell you
I'll give you $1.55.
You know your book costs $70-something dollars without the fact.
Ain't my book.
Get you a candy bar, girl.
Do you understand? Somebody has to do the math. Somebody has to do the math. Have you got my 3.33? No, I'm working that. Oh, no, oh my God. That's not fair. That's not right. Hang on, I'll show you.
Whoa! Alright. Okay.
Yeah. What'd you get? No. Listen to let me show you what he did. You all look what the hell he did. You know what he did? He took 1/3 and changed it to .333. Y'all get, oh my Lord. Oh my gosh, he took 1/3 and made it .3. Damn, I didn't know it was too bad. That's what you did. I didn't tell you to do that. I told you to do what? I told you to take the .333 and make it back to the third. I guess. Now here, y'all listen to me a second. Do you see what I was making the point a minute ago when I had the 0.5 up here and they went immediately to 1/2 without showing me how they got there? No, hush. Without showing me how they got there, okay? Do you see why I was busting the Raising Cane? Because why? Because you need to know how it happens and how you get there.
333 over 1,000.
Well, look, y'all hold on 1 second here. This problem is so important. You've got to know about this because it plays some important role in the way math behaves. Because what you really can do is you can find the sum of an infinite series. Did you hear what I just said? Finding the sum of an infinite series. Because is this the same thing as this?
Yes.
Do you all see that? Is that not the same thing as .3333 forever? Right?
Yes.
Is this not an infinite series?
It is an infinite series.
Do you see this, everybody?
It
Did
is.
you actually realize that you can sum in mathematics an infinite series? What do you think you get here? If you sum this infinite series, you're going to get 1/3. Now, I'll show you how to get to that point later. But for right now, you can do this like this. Everybody see that? I want you to multiply both sides by 10. And that's what you'll have. Correct? Yes or no?
Yes.
I'm not hoodwinking you.
Yes.
Everybody see that? I want you now to subtract an x from both sides. What is this?
Negative
10. How the hell 10 rabbits take away 1 rabbit? 10.
Oh, 9.
9 rabbits. 10. Good grief. So if I subtract an x from the left side, I must subtract an x from the right side. And there's x, folks. You see it?
We're not speaking unless you confident.
Never
Because all the 3's go away. Can you see that? Are you watching me?
Yes. Let me
You
write
better
that.
be.
Let me write
It's
that.
3 9.
X is equal to what? 3/9, which reduces to what?
1/3.
And you actually started off saying that x was actually the decimal .3333. Some of you look shell-shocked. Somebody has to do the math. You see why I still have my 55 cents?
Because we were wrong.
Somebody wanted to take the debt for 55 cents? You need it while we're on cell phone?
If that give you any clues?
No, yeah, I got it.
Oh yeah, you know.
No, I
don't have to work. I'm naturally.
Oh, no, we're good. We don't even need to talk about it. We don't even.
The reason why I have that card is I've been 16 cards. I've had 5.
Okay, everybody look up here a second.
That's because.
If you do this,
I'd rather look at Walmart than Kmart.
And this one makes this pretty interesting. Do we have calculators here? You have anybody who's have a calculator? You got one?
My cell phone give me my
Yeah,
calculator.
you ain't gonna have a cell phone with a calculator.
Yeah, exactly.
You really need a calculator.
What about 0.6666?
I want you to do this. I want you to take the number 1, put that in your calculator.
Come on, Galaxy.
You ready? I want you to multiply that number by 2. I want you to multiply it by 3. I want you to multiply it by 4. I want you to multiply it by 5. And I want you to multiply that number by 6. And tell me what you got. Start over here.
285714. 428571.
What? 428.
8571.
571428.
714285.
714285.
857142.
1-800 cash now.
I want you to look at that, everybody.
They're all the same.
They're all the same number, just arranged numerically different. I want you now to put this number back in your calculator. You get it back in the calculator? I want you to multiply it by 7. Now that's pretty nifty.
1-4.
That's pretty good. Is that what you got?
Oh, no. What a cool.
Pretty good.
Good.
So why is that cool?
Straight 9.
It is simply because I can do this. I can say let
That's cool.
x equals that number. If I multiply both sides by what? See that, everybody? I get that, right? I multiply both sides by 1,000,000. Subtract an x from both sides.
Did you get in your head? One.
7.
Reduces to 1/7 quickly. That's pretty nifty, right?
Yes.
Is it just for that number or what?
It's what?
Is it just for that number or is that some special number?
No.
No.
How about that?
1-1-1-1.
Is that rational?
Yep.
Yes. Change that to fractional form. You ready? Multiply both sides by 100. Why 100? Because you must always put the decimal between the repeaters where the repeaters start. So it requires a 100th place over. Now I want you to subtract not a 1x from both sides, but a 10x to make the arithmetic a lot easier. How about just 10 of these? You see that? Just that easy. Yes.
Question.
What?
Since you're really good with this, like number crunching, isn't this just like lottery? Like you have so many chances of winning, and then would you end up with is like 1 in 6 chance of winning?
No,
I think they just give you that lottery number. I don't think they got a chance. I play lottery all the time. I sell my body for money.
Can tell.
what's fantasy 5? Pick 5 numbers out of 39, 1 to 39. Is that it?
You better tell us how to pick lottery numbers.
No, he's going to probably tell us the chances.
Oh. That's what I just said.
Calculate that. No, that doesn't mean 39. That means what? That means 39 factorial. 39 factorial. What is 5 factorial? It is what you get when you multiply 5 times 4 times 3 times 2 times 1. So calculate that. This becomes what? 39 times 38 times 37 times 36 times 35. How much is 39 minus 5?
34.
So now, this will cancel, that will cancel, the 2 will cancel with what? That's 18, right? 3 will cancel, 3 6 is 18, right? 4 will cancel with what?
38.
What's 4 divided with 38? No.
Nope. It was wrong.
5 will cancel.
35.
5 7, right?
7.
This
We're
is
talking about
2.
what number?
What will this go? 2 divided this how many times?
Oh, me no.
Hurry. Take a calculator, divide that number by 2.
Who's a calculator in mine?
How much?
19.
Divide this 2 by this, you get a 3. So how much is 39 times 19 times 37 times 3 times 7? Do that arithmetic. Hurry.
5, 5, 7, 5, 7.
How much?
5, 7. Yeah, 57, 57.
Is that it?
Yeah.
Is that what you got?
Is
Is that what you got?
Is
Is that what you got over there? Next time you pick up a Fantasy 5 lottery slip, look on the back of it and see what's the odds of winning. 1 out of what?
No, it's
You didn't win
you didn't.
57.
What now?
More
There's
numbers.
dyslexia caught in. It's 57.
Whatever, I don't know.
No,
It's
no.
what?
57.
3 times.
50. No. 500. Shit.
5, 7.
507.
7.
Yeah.
5, 7. 5, 7.
Put a comma between the. Yeah.
Is that it?
Yes.
That's not what I had written up there?
No.
Huh? Is that what I had written up there while ago?
No.
I don't know what I had. Look at this, look at the back of the lottery ticket. You'll find that number on the back of the lottery ticket. Fantasy 5.
I play like.
If this is correct, is it 39 numbers, you choose 5, right? Yeah? 39 numbers, choose 5?
You should know the probability of when the number should fall then.
What now?
You should know the probability of when the number should fall.
What you just say?
You should know the probability of when the number should fall.
Of course.
Oh my goodness.
How might one calculate that?
Today's lesson in math, how to play the lottery.
Yeah, it's cute.
I'm trying to buy Eric a new cell phone.
Why? What's wrong with this?
What's right with it?
What does he have?
A Walmart S1.
It works, okay.
Jeez.
Why you being
I'll throw in my Corey in the car.
I wrote a computer program once that
At very least give her a
I
pass.
would, I could generate numbers
Buy her
from the
some bus
lottery
tokens.
in a biased way. And I could sell you a ticket if you'd give me $2 for a ticket, and if you didn't win anything, then I'd give you the $2 back. And I'd come out ahead. That's how good my program was. Of course, most people wouldn't believe me, but
How would you come out ahead? If you
because I'd
didn't
get
win,
to
you
keep
get back.
$2 every time you won something.
You win $1.
Oh, so you're only making the ticket cost $1? I mean, you're only making the prize $1? He said that he had a lottery,
Yeah.
and for every ticket you bought, if you lost, you could get $2 back to the amount of money you bought for your ticket. He'd come out ahead. He had to win. The prize only had to been $1.
You gave me $2. I'm just getting back here. Here it is, right here. Here's your $2.
So how did you come out ahead? You should have broke.
Because you bought the ticket. You buy the ticket, you get the $2 back. If you didn't win anything.
So how am I ahead?
You won't be. I will be.
I don't understand how you're
I
ahead.
don't want you to be ahead. I want to be ahead.
How are you ahead if you gave me my money back?
Because I'm gonna get to keep a lot of those $2. Because my
How much is the
computer
prize?
program, I didn't say you to win the whole jackpot. I just said if you won something.
You say you want $2 out of a whole.
You might win a ticket.
Just forget it. Just,
My program was based on the numbers that had already been played and had come up. Did you realize that
So
the
you
number
tried to
24
reinvent
had
the
come
lottery.
up like 4 times more often than like 27 like that? How many people realize that?
What?
I think the number 24 would come up something like 7 or 8 times more often than the number 17 or 19 or something. I had it print out exactly every number from 1 to whatever numbers it was, how often each one of them came up. And some of them came up more often than the others, significantly greater chance of it being won. So my selection of a 6-number ticket for you was what? Was drawn from that weighted bias. And everybody that I used to play the game with, they won more often than ever. They didn't win every single time, but they win more often than they had been in the past. But anyway, that's neither here nor there. That was years ago. That was an old, slow computer system. I wish I could rewrite it in a different format to make it a lot quicker program. I could do
15
that.
minutes on to make sure that.
And I just didn't keep up with the data
Zeros and ones.
because what it amounted to, somebody has to input the data every single week that a number is played. You got to put those numbers in, and you like to put them in the order that they came up in. Your ticket is printed out what? In orders, and the numbers are printed out in order in the paper or whatever, or on the computer. So, but it didn't come up that way. It may have come up 17, 6, 5, 9, 11, whatever. Okay, anyway, what were we doing?
About to go.
I can't remember. It's time to go, isn't it? How about, is it close to time to go?
We have 5
Yep.
minutes.
Almost, isn't it? What time was it?
Oh, it's.
We started at 12:30.
We got 20.
Yeah, no, we got 5.
Yeah, we got a few more minutes here. Anyway, I want you to be thinking about the number system and exactly how it works and why it works like it does. And we're just lucky that it works out like it does. Because of the continuity between the numbers and the smoothness between the numbers, it does what? It means you can actually go from 1 to 2 to 3 without making little what? Quantum leaps. You go really what? it goes smoothly. It couldn't be any more perfect than that. That's absolute perfect system. That's the beauty of the whole thing is due to that continuity. And what's so confounding about that thing, you all, it should be confounding to everybody that thinks about it, that number line is made up of, guess what? Something we have called points. Points. You cannot imagine a point even in your mind. It's impossible to imagine a point because a point has 0 dimensions. You cannot even think of something with 0 dimensions. Do you all get that point? I mean, do you get the concept of what I'm saying?
Yes.
Of how that's so intriguing that that line is one-dimensional. The point is 0 dimensions, but yet we make the points do what? Make up the line that exists only in our head and nowhere else.
How about a shadow? That's a line.
That's the only two-dimensional thing I can think of.
A shadow?
A shadow. I cannot think of anything other than a shadow that's two-dimensional.
What's as heavy as an elephant, but light as a feather? I mean, what is as big as an elephant, but light as a feather?
Air.
An elephant shadow.
I didn't ask you a question. I don't understand.
I think it's lighter than
It doesn't matter at Walmart.
But listen to me, because the way our system is put together and the way our system just sort of fits.
I don't have to work.
How about if we ask you this question? Now, I'm sure some of you have taken my class before, you've heard this before, but can I theoretically go from point A to point B? Because when I say that, before I can get from point A to point B, I first must walk what? Halfway. Am I to point B yet? No, because I've yet to have to walk what? Halfway yet. So I go halfway. Am I to point B yet? No. Why not? Because I'm yet to walk what? Halfway. Am I to point B? No. So I walk halfway. Am I there yet? No. Theoretically, will I ever get there?
No.
Who else said no? Who said no? I go from point A, I go from this side of the wall to this side of the wall every day, and I can touch it and touch it on this side. So if that is the case, why am I able to do that? It is simply because if I sum an infinite series, if I sum that infinite series, and it certainly is an infinite series, what do you suppose I get? What do you suppose I get? You get one whole trip. That's why I can go from point A to point B, theoretically and physically. It's mathematically possible. Does that make sense? No, not really. How can you possibly sum an infinite series? You can do so mathematically. That's how. You can prove this as a fact.
Prove it.
I took a picture of myself. I
I don't want you to take pictures of me.
swear to God.
Stalking me.
There it is right there. That's the equation for y. Sum of the geometric series.
Yeah.
All you have to know is the ratio between the two of them. The first number was what? 1/2. This is 1. And what is the ratio between any two of those numbers?
There, keep it.
That's what? You see that? Does that make sense?
Yeah.
Yes, that's a geometric series. It is sums any geometric series provided you know the starting number and provided you know what?
The ratio.
The ratio between any two of the values. I better go because most of you shut down anyway, so.
Yeah.
Yeah, most of you, most of you
I've been thinking,
shut down 5 minutes ago. So,